Hello, Mr. Collier here. Right now we're going to give you some notes on Chapter 5, Section 2, which is all about friction. Just a reminder, in Section 1 we defined forces as anything that can cause acceleration, and we looked at one example of an at-a-distance force, which is gravity. Friction, in this section, is a contact force, so things are going to be in contact. Let's start by defining friction. It's a force that resists the motion of objects, and so it's always going to oppose the motion that you want to happen. When two objects are in contact, one type of friction is going to happen because of the microscopic hills and valleys that occur between those surfaces. There's lots of different types of friction. Let's look at some of these two solid objects touching, right? The first is called static friction. I'll talk a little bit more about this on the next slide, but static friction is the friction you have to overcome to get an object that's not moving to start moving. Sliding friction, which I'll also talk about in a couple slides, is when one object is sliding across another, and that is a different type of friction. Rolling friction is when things are rolling. Their names are very descriptive. It's quite helpful. And when rolling friction occurs, if you think about it, you've got a much smaller area that's touching the surface, and so rolling friction is going to be a little bit less than sliding friction. Over here on the right, we've got a whole different other class of friction. These are called fluid friction. You can have friction of an object moving through the air resistance. We're going to see lots of examples of that as we discuss. And viscous friction would be through fluids like water. So, because friction is a force, we're going to measure it in newtons, just like any force. Static friction is going to be that friction that I mentioned that you have to overcome to get an object to start moving. So for example, if you can't overcome it, say you push with 10 newtons to the right, and static friction is 10 newtons to the left, you did not overcome it, and it is not going to move. Sliding friction will what you have on your hands once you've started an object moving. So say you pushed with enough newtons, say we go 100 newtons of pushing, and now we're moving, and sliding friction is giving me 20 newtons. It's going to decrease the overall effect of my force. We're going to talk about that in the next section when we talk about net forces. Friction is going to depend on a few different properties of a material. For example, how rough it is, and how clean the surfaces are, and a bunch of other factors. And another thing that's going to affect friction is how hard are the two surfaces in contact, like how much pushing together is there. And you can probably picture something like this. If you take a piece of paper and drag it across the table, nice and easy. You put a brick on top, all of a sudden it takes a lot more effort to pull it. And that's not just the inertia of the brick, that's also the additional friction between the paper and the table. Because friction is this force that's resisting motion, we're going to want to decrease it under certain circumstances because it's resisting the motion that we're trying to achieve, like a train going down the track or a car on the road. We can't completely get rid of friction, but we can reduce it. So let's talk about a couple different ways. One way to reduce the friction is by changing the type of friction. So for example, I mentioned earlier that sliding friction is greater than rolling friction. So one way to do it would be to change from two objects rubbing together to put ball bearings between them so that now there's less friction. Another way we can reduce friction is by adding a lubricant, something that makes the surfaces slippery compared to each other, like motor oil. And that's going to also change the type of friction. Basically, you're going to have a viscous friction instead of a sliding friction. There are, however, situations where you want more friction. For example, you want your tires to grip the road so that they don't slip and you don't get into a car accident. So we have grooved tires which are there to channel away the water so that more of the tire can grip the road and the water doesn't make them slip. Other situations where you want to increase friction would be when you're running or performing sports. You're going to want your shoes to grip the ground so that you don't slip. And different circumstances are going to require different kinds of tread. So just walking around, you're going to want some grip on your shoes, but not too much. Whereas if you're playing something where you're running around in dirt, you're going to want pointier treads to stick down in that dirt and get you some friction that way. And of course, another example would be stopping a car, right? We don't want our cars to go on forever. We want to be able to stop them. So brakes work by creating extra friction and slowing down cars. What friction does, besides resist motion, is it changes the energy of motion into heat energy. So friction's always going to warm things up. You're going to get thermal energy out of it. And that's going to make things wear down or overheat, right? So that's why we need to, another reason we need to limit friction and regulate it. If you picture rocks that have been in a stream for a very long time, you know that they're going to be worn down and nice and smooth. And that's kind of one of the real shows of how powerful friction can be. And that's it for this presentation, section 5.2 on what is friction.